Hi guys, welcome to another video. Today we're going to be looking at statistic on probability. So the first thing you want to do is prior knowledge check. So why don't you guys pause the video and have a look at this three question. Okay, so for part A or 1A, 2/9, 4/9, 2/3 and 0 for D. For question 2, these are your possible outcomes for 3A, 3B and 3C. So an experiment is a process where you keep repeating until you get certain outcomes, and we call that a experimental probability. An event is a collection of one or more outcomes, and a sample space is a set of all possible outcomes. Sometimes you're asked to elaborate on each of this jargon, so it's worth just reading through this. So let's say if we had two spinners numbered 1 to 4, both are spun and the sum of the numbers is x is calculated. What we want to do is find probability of x equal to 5 and probability x greater than 5. Remember, we're looking at two spinners here. So we could draw a sample space to show the outcomes. So this is spinner 1 with the 4 outcomes and spinner 2 with the 4 outcomes. And we're told it's the sum. So that means you're adding them up. And you would have seen something like this in GCSE, a sample space diagram. So if we ask to find the probability of x equals to 5, you can see it's actually 4 out of 16, which we can simplify as a quarter. That when we ask to find probability x greater than 5, well, all of these numbers, 6, 7, and 8, are greater than 5, and that's 6 out of 16, which is 3/8. So here, the table shows the time taken in minutes for a group of students to complete a number puzzle. And the question here says estimate the probability that student complete the puzzle in under 9 minutes. So if it's under 9 minutes, these are the group that we're interested in. And in total, 6 plus 13, so we've got 19 out of 40 people that completed it under 9 minutes. Part B of the question, it says estimate the probability the student completed the puzzle in 10 minutes or above. So if it's 10 minutes or above, it's kind of overlapping with one group, which is between 9 and 11, and then we've got the other two groups. So we'll go for 15/40. Okay, so another way of illustrating probability is using a Venn diagram. So the S here is the sample space, or sometimes a Greek letter psi or epsilon is used. The circle represents the probability of B. This is probability of A. And in a Venn diagram, this bit, the bit in the middle overlapped, we say this is a probability of A and B happening together. So another way we could write this is in this format, P bracket A intersection B. And that's what the curved N shape means, is and or intersection. So here, if all of this is shaded A, B, and the intersection, we say this is the probability of A or B happening. And the way we could write this is P bracket A union B. Okay, so the union here would represent the intersection. Everything that's shaded. So in this one, we've shaded everything except for A. So the area outside of A represents the probability of A not happening. So if we want to draw a diagram, not A, this is what we would shade in, something like this. So let's have a look at this question here. It says a card is selected at random from ordinary playing cards of 52. Let A be the event the card is an ace and D be the event the card is diamond. We want to draw a Venn diagram to show this information. So Once we draw out the rectangle for the sample space, we could start drawing the Venn diagram. So this is the A for the ace, D for diamond. So there's only one card that's ace of diamond. So we'll put the one in the middle. And there are 4 aces, but since we've already put one ace of diamond, there are 3 more aces left. So that's where the 3 here comes from. And the 13 of each suits of playing cards. So D is 13, but since we put 1 here, we have another 12 there. And what's left over is 36, because from 52 playing cards, if you take away the diamond and the ace, you're left over with another 36 cards. So now we want to work out probability of A intersection D. So probability of getting ace of diamond. Well, there's only one of them out of 52, so it's simply 1 over 52. Probability A union D, the probability of an ace or a diamond. Because it's union, if you recall by the shading, we're looking at all of this. So in total, it's 16, 12 plus 1 plus 3. So we've got 16 out of 52. Okay, probability of not an ace, probability not A. So we look at everything except for A. Well, if it's except for A is 4. So from 52, if you take away 4, you have 48 out of 52. Which you can simplify 12 over 13. So here, if we're looking at probability of A, not A intersection D, what we're saying is, what is the probability of not being an ace and being a diamond? So not an ace and a diamond is actually 12 out of 52. Which you can simplify as simply 3 over 13. So let's look at another example. Here it says in a class of 30 students, 7 are in the choir, 5 are in the school band, and 2 are in both the choir and the band. It says to draw a Venn diagram to show this information. So why don't you guys pause the video and have a go at this. Okay, so your Venn diagram will look something like this. B for band, C for choir. We always start off with the intersection. It's always an easy option to start off with. There's 2 people, and then there was 5 students in the band, but 2 are in the choir, so we put 3 there, 3 out of 2, that'll give us 5. 7 people in choir, but we've got 2 there, so we need to put another 5. And we're told there are 30 students in total. So for 30 students, there must be 20 that's not in the band or in the choir. Okay, so let's work out the probability of not being in the band. So probability not B, well, it's just going to be 1 minus probability B. So 1 minus 5 over 30, because the probability of being on B is 5 out of 30. So the answer to the probability of not B would be 25 over 30, which you could simplify as 5 over 6. So here's another question. So sometimes they will give you a complete a shell version of a Venn diagram. Okay, like this we have on the diagram, and they'll ask you to fill in, or sometimes you'll be filled in and there will be a question to answer. So why don't you guys pause the video and fill this information into this Venn diagram. Okay, so it's always best to start off with the middle bit, which represents all 3 pets, which is 7. 15 have dogs and cats, so 7, you take that away from 15, because don't forget, people that have dogs and cats, they also have dogs, cats and fish. So be careful not to put 15 here and put 8 there. The same way, if 10 people have cats and fish, we have to take 7 away from the 10, so it would be 3 in here. And again, 11 have dogs and fish, we have to take 7 away from the 11, so we'll have 4 there. This is why it's very important you start off with the middle bit here, the 7. Now we could fill in the rest of the Venn diagram. 25 have dogs, so if you add up 8, 7 and the 4 and take away from 25, so that'll leave you with 6, so we'll put 6 there. 53 have cats, so same as before, if you add up 8, 7 and 3, take away from 53, so we'll give you 35 here. And same for fish, if you add up 4, 7 and 3, take away from 40, we'll have 26 there. So now what we do is remember to work out how many people have no pets. So we ask 100 clients. Okay, so you add up dogs, cats and fish and you take that away from 100, so that'll be 11 people. So now we ask the question, what is the probability of a client having dog only? So dog only would be that 6 out of 100. Don't include the other numbers because that's not dog only, that includes other animals too. So it'll be 6 out of 100, which you can simplify as 3 over 50. Next question is, what is the probability of someone who doesn't own a fish? Okay, so don't own a fish would be these people here. Dog only, cat only, a dog and cat, and people who don't have any pets. So you add them up, that gives you 60, so 60 out of 100. Which you could simplify as 3 over 5. And the next part of the question, it says, what is the probability of client having none of these? Just simple, 11 out of 100. Okay, so here's the answer for part A. You draw the Venn diagram, B, C, and D. Okay, so now what we're going to look at is what we mean by mutually exclusive and independent events. So mutually exclusive is an event where, so two events where it can't happen at the same time. So for example, flipping a coin, you can't get head and tail at the same time. Now it's perfectly you could get head and you could get tail after, or vice versa, but you can't get at the same time, and that's what mutually exclusive is saying. Another example would be, you're turning left and right at the same time. That's not possible. You could turn left, you could turn right, but it has to be one or the other. So when we say mutually exclusive, this is what we're referring to, that A and B, A intersection B equals to 0. And on the Venn diagram, it will look something like this. There are no overlap because A and B cannot happen at the same time. So if we consider the Venn diagram to the right, what we see for mutually exclusive, we said they can't happen at the same time. So probability A union B will be probability A plus probability B. You can also work out backwards. If the above statement is true, then the events are mutually exclusive. Okay, so independent events, when one event has no effect on the other, they are said to be independent. So for example, the probability of event B happening at the same time or not has no effect on A. So a classic example would be flipping a coin and rolling a die. So the fact that you get head on a coin and, for example, 5 on a die, they both are independent of one another. The die has no effect on the coin. So for an event like this, independent events, we say the probability of A intersection B is equal to probability A times probability B. And the reverse is also true. So just like an algebraic manipulation, you could rearrange this. So you could say the probability of A equals to probability A intersection B over probability B, or any other way you want to rearrange it, it'll be perfectly fine. So I've got both my equation written here, the mutually exclusive event and independent events. So I'm going to take a question here. So let's look at this example. It says events A and B are mutually exclusive. Probability of A is 0.2 and probability of B is 0.4. So to illustrate this on the Venn diagram, remember they're mutually exclusive, so it's not going to overlap. So I'll have my 0.2 here, 0.4 there. So total probability adds up to 1, so we'll have 0.4 outside here. So we're going to work out probability A union B. So probability A union B, remember you add all of them up. In this case, there are no intersection. So it's just simply probability A plus probability B. 0.2 plus 0.4 equals to 0.6. Part B of the question, we're going to find probability of A intersection with not B. So A intersection, guys, with not B, which is just probability of A. It doesn't obviously intersect with B, so it's just going to be 0.2. So part C, we're going to work out probability of not A intersection with not B. So we could just simply write this as 1 minus probability A union B, which is 1 minus 0.6, gives you 0.4. Now we have events C and D, and they're both said to be independent. Probability of C is third, probability of D is 1/5. We want to calculate probability C intersection D. We know probability C intersection D, and the formula is written above as well. You can see that's same as saying probability C times probability D. So in this case, just a third times a fifth, which gives you 1/15. And if we were to construct the Venn diagram, because it's independent, they both could happen at the same time. They could have an overlap. So in this case, the overlap is 1/15, C and D. So now we could work out what probability of C is, just C, because probability C is a third. So from a third, we take away 1/15. So just this bit here is going to be 4/15. And similarly, if you do the same for D, we know D is a third. From a third, if you take away a 15th, that will give you the 2/15. Okay, and the outside bit will be 8/15 because you would have to add up a total of 1. Now we asked to find probability C intersection with not D. So C, which is this here, not intersection. So we can't include the 1/15. So it will be just 4/15. Part C, we want to find probability of C, not C intersection with not D, which would be just the outside bit, 8/15. No C, no D, no intersection, so it's 8/15. So here's another example. The Venn diagram here shows a number of students in a particular class that watch any of the 3 popular TV programs, A, B, and C. Find the probability the student watches B or C or both. Okay, part B says determine whether watching A and watching B are statistically independent. So there are 30 students in total. 26 watch B or C or both. So it would be 26 out of 30. Another way of writing this would be 13/15. Probability of A, well, A is actually 7/30 because you do the 3 plus 4, all of this is A. Probability of B is 19/30, again simply just adding them. And A intersection B is 4/30. And we asked to determine whether A and B are independent. So we know the formula for independent is probability A times probability B. Probability A 7/30, probability B 19/30. And if we calculate this, we see that we've got 4 over 30 equal to 133 over 900. So now if you give this a common denominator, we'll clearly see it's actually not equal. So as the rule for independent does not work, the events are not independent of each other. So here we could see clearly probability A and probability B are not independent events. So there's a 3 question for you guys to practice. So why don't you pause the video and have a look at this question. Okay, so for part A, or the first one, you should have got this. Second one, they're not independent. And the last one, x equal 0.3. Okay, so we're going to move on. So we're going to look at another question, and this time it's going to involve drawing a tree diagram. So a question: a bag contains 7 green beads and 5 blue beads. A bead is taken at random, the color is recorded, and the bead is not replaced. So when you get a question like this in the exam, highlight the word if it's replaced or not replaced. So in this case, it's not replaced. A second is then taken and the color recorded. And the question says, find the probability of getting 1 green and 1 blue. So first of all, probability tree diagram, you guys would have met this in GCSE. So the way it starts off with is green and blue, or green 1 and blue 1. And then if we extend the green this way, we'll call that event of green 2, and blue 2, green 2, and a blue 2. The probability of picking a green the first time round is 7 out of 12, because there are 12 in total, 7 plus the 5. There are 5 blue in total to start off with, so it's 5 over 12. So on the first picking a green is 7 over 12, picking a blue is 5 over 12. But since it's not replaced, if we follow the green, it says we picked a green. So if you picked a green, you go 1 less of a green, and you go 1 less in total. So it'd be 6 out of 11. If you picked a green, blue is not affected, so blue would be 5 over 11. On the other hand, if you picked a blue the first time round, then the green is not affected the second pick, so it'd be 7 over 11, and the blue would be affected, so 1 less, so it'd be 4 over 11. And you should always check that they add up to 1. Each one of these branches, make sure they add up to 1. So now the question is, what is the probability of picking a green and a blue? So getting green and a blue, these are the possible ways of getting green and a blue. So we could get green the first time and the blue the second time. Or, since it's or, we could get blue the first time and the green the second time. So picking a green and a blue, and would mean you multiply. So 7 over 12 times 5 over 11. So that'll give us 35 over 132. Getting blue and a green, the word is and here in the middle, so we need to multiply 5 over 12 times 7 over 11. So that will give us 35 over 132. So you simply add them. So that gives us the probability of getting green and a blue, 70 out of 132. So we could simplify this, say probability of green and blue is 35 over 66.